My name is Alexei. Today we're going to be talking about how to save a ton of money. So I think that we can all save some money in today's economy. Who here, by a show of hands, uses a SaaS observability product like Datadog or Dynatrace? So basically the entire room. Okay. Well, we're all friends here. Shout out, what are some of your favorite features from these products?
Fast log searching.
OpenTelemetry, fast, how fast it is, how reactive it is. Anything else you like about these SaaS tools? Traceability. What's something that you don't like about these SaaS tools?
The bill.
The bill. Okay. Right? So that's usually what I hear whenever I encounter and talk to people about observability solutions is the cost to value ratio. Right? It's gone completely the other way. It used to be turnkey, you plugged it into your architecture, you got all this value out, but as they keep building this tool and maturing it, they end up just not providing the value that we want anymore. Who's on call here for the software they write? Who's on call right now? Okay, there's no. There's actually no one on call right now. That's good because that means you have to bring your laptop, hopefully. So when you're on call, how do you know your observability solution is functioning?
I see live logs.
You see, but no, I mean like right now, you're sitting right here. How do you have the confidence? How do you have the confidence that you're going to get your PagerDuty alert right now?
This phone is not ringing. That's fine.
Yeah. But that means something could be burning, right? Right. So.
Alerting statuses on certain.
Exactly, right. So. By giving away the keys to these SaaS providers, we inherently give away the trust. We trust that they're doing their job, their uptime is 100%, to alert us that our uptime is 100%, right? And by doing so, when we first did these things, we used their proprietary agents. We used the Datadog agent, we used the Dynatrace agent, and we've locked ourselves into these vendors. And they control one of the most important aspects is production on fire. Right? That's a scary thought that we're giving away all this. And it's a black box. We can't run Datadog locally on our laptop. We have no idea what they're doing. Right? So today we're going to go through a story at a company that I worked at for half a decade, Yukon Games, how we migrated away from Datadog to an open source observability stack. But before that, I want to promise one thing from tonight. Everyone in this room will be able to leave tonight with the confidence to implement an open source observability stack tomorrow morning by 9:05 a.m. You will be able to run an open source observability stack locally on your laptop, logs, traces, and metrics, all on your laptop, and you're going to be able to pitch it to your head of engineering at 9:30.
Will we be able to deploy it somewhere by noon?
If you try hard enough with Claude. So that's what I promised today, but let's get into the story. So Yukon Games, let's see if that, yeah. Yukon Games was a company I worked at. It's a startup or kind of startup vibes. It's been around for a while. It was founded in 2009, and it's a video game company that I worked at. Over the years, they've had millions of players. They're part of really, really big brands like Sony Pictures, Apple, and Tim Hortons. We built a number of games, and one of the games was notably sold for $100 million to a Silicon Valley company. Right? So you can see there's a lot of stuff to monitor and make sure there's a good uptime. If these games go down, brand reputation, right? No one's going to start hiring Yukon Games anymore. So it's very important to build really high-quality software. One of the games that I got to architect from the back-end perspective along with another engineer was Tim's Word Challenge. This is built right into the app of the official Tim Hortons app. If you have the Tim Hortons app installed on your phone right now, you can play this game. Millions of Canadians have enjoyed it with their morning coffee. It's been live since November 2023. And we've actually had users that have played every single day since launch to maintain this one little daily streak counter. Yeah. Right? When you give users these leaderboard incentives, you'd be surprised what people go to. The lengths, right? A funny story, I was at a metal concert at a festival, I'm a big metalhead. And last year, we're walking out of the festival, like 40,000 people pouring out, trying to find an Uber. We're walking, we're trying to get further away from the venue to actually get this Uber. And I hear my friend behind me yell, "Oh my God, oh!" And I was wondering, why are you yelling? Do you have a heart attack? What's going on? And I turned around, he said, no, no, no. My Duolingo streak was about to expire. And I was like, wow, how powerful gamification has, not just in the gaming industry, right? But outside in these more like educational apps, something that you think would be boring is starting to gamify things with these just simple streak counters. So the question that we always ask ourselves when we woke up every morning is, how do we know if players are having fun in our games? That's the most important question in the video game company. If people are not having fun, people are going to churn from your app. They're going to go play something more fun. There's new games every day being made, especially now with AI. So let's take a step back. Let's define what observability is. I would say there's two main aspects to observability. At the top, we have product observability. Product observability, more commonly known as product analytics, maybe in our spaces, is things that matter about our business. In the video game industry, these are some of the high-level metrics that we would look at. How many levels has a user completed? How many in-app purchases have they made? What's our daily average user count? How many people are actually playing the game every day? Session lengths, and the other most important one is retention. By day 7, what percentage of users stay in the game? How many are still playing? Because if users aren't staying in the game, then we can't monetize them. We're going to focus for this talk on tech observability. I would say this is like the foundation to your house. If you can't monitor these or know that they're performing well, there's no way in heck that you're going to be performing well on their product observability, right? If your uptimes are poor, if your latencies are high, it doesn't matter. You're not going to have a good DAU. No one's going to get through any levels completed. So it's really important to have this figured out, and most of us in this room are using some sort of SaaS product at the moment. But you might be asking, it's just a mobile game. We're building these mobile games like Who Wants to Be a Millionaire in Jeopardy. What kind of backend is there? You're sitting on a subway, you have no network connection, it's not multiplayer. What else could you need, right? But at Yukon Games, we have to monitor many different containers, dozens of EC2 machines, databases, hundreds of service deployments. To do this all by hand obviously is impossible, but we had to end up building out this architecture that could take all these metrics, these traces and these logs from all these different services and aggregate them into one place, which was Datadog. What do you guys think in this room that a video game might need? What's the type of service that somebody might need to build for a video game? Sorry? What kind of backing service, like does a video game, let's say, need that it specifically needs a backend for?
Ability to sell in a game.
Yeah, so monetization, right? So integration with app stores. You have to have integration with all the app stores, Google, Apple, right? Another thing, push notifications. How do you register all the tokens of each device across the world? How do you send them a mass push notification to come back into the game, right? Inventory, cloud save. If your phone drops, breaks, and you come back on a different device, are you going to get your progress transferred to your new device, and can you continue playing? Right? That's a very important service. And the most important one of all, which I've already alluded to, is leaderboards, scoreboards. If you have a ranking system, the number of tickets we've gotten where people are like, I was first, this guy came out of nowhere, now he's first, he's cheating. People get very, very competitive, right, on trying to get number one. And they pay lots of money. Right? Some of the top paying users, who wants to hazard a guess, over 4 years, who paid the amount of money that they spent in one of our games?
The amount?
Yeah. I can't say the exact amount, but I'll give you a ballpark.
I'm afraid to know.
Over 4 years. So over 4 years, one of the top paying users paid over $200,000 US playing a mobile game.
Wow.
So these people are serious. They have cash and they're serious. And they're going to give the money to you if you give them a good time.
And he still drinks into more.
Sorry?
To more to guy.
Oh, no. Yeah. Right. So these people have deep pockets, and we would term them as whales, right? And so we give them VIP treatment. We would sign them up for SMS VIP programs. So we do SMS integration. You'd be given like a white glove service. People will be coming in. They come in, sir. This is your video game, right? So it's really important to be able to monitor all this kind of stuff. The next piece that I also got to work on, and actually I presented this new architecture at a talk in Austin, Texas back in current 2022. It's a Confluent-led conference where we re-architected our pipeline instead of from JSON emitting all our analytics from our mobile devices to protobuf. Right? So we ended up using Confluent Schema Registry to make these schemas visible within our processing infrastructure. So this pipeline would handle hundreds of millions of events per day. Anything you're clicking in the app, how many levels you've won, what ads you've watched, everything's being monitored. And in real time, we're customizing your experience. We're giving you real-time store offers that are customized to you, right? So the app is watching, but it's watching to make the game better. What if you're losing too often, right? What if the game's too hard? Who here finds a game fun when you're losing all the time? Nobody. Who here finds a game fun when it's too easy? Nobody. What's the solution? It's something that we call in the industry a difficulty curve. It's a sinusoid. The game will be tuned such that your dopamine is always going up and down, and that's what keeps you in the game, right? So video games is really combining psychology, engineering, and marketing. And when you combine these three, they form something very powerful. And how do you get users enticed into your games? So this pipeline enables all of this, right? All this analytics. Then you obviously have to crunch the numbers. There's a data platform to monitor as well. There's hundreds of data jobs. We're combining different data sources from the protobuf logs that we've sourced in S3 to our Redshift data warehouse to external APIs like the ad providers. And then you combine all this data together and build a nice dashboard for your CEO or product manager. And they get to decide, did that A/B test win? Are we going to release this feature? Right? So there are a lot of things to do. So we monitored all of this with Datadog. Datadog was our solution before there was New Relic, I believe, before I joined. And then Datadog was the kind of the latest and greatest tool. But don't be fooled by the cuteness. It gets you. It's very cute. You want to hug it, but it sticks to you, right? It gets its claws right into you, right? So you got to be careful. What's there to be careful about? Well, the convoluted pricing structure. We probably all stare at this screen longer than we care to admit. Every time we come back to this screen, we've done some optimizations. We come back next month, it somehow got higher. And we haven't deployed any new services, but it's higher. You need a PhD to figure out your definitions. It's just like a textbook of definitions per feature. How do you define a host? Oh, how do you define a container? Are you going to pay 0.002 cents per container per hour? But in addition, you can purchase prepaid containers at $1 per month. Per container per month. All I hear is per. Maybe they should have called it data cat. And then you have this matrix. So all those definitions multiplied by this matrix. Who has time to do this? You want to ship features. You don't want to be figuring out how to reduce your costs with this vendor. So there was an inflection point. Essentially, at some point, the contract negotiations with Datadog got out of hand. They jacked the price. We're kind of stuck with this price hike. And they went up to $70,000 per year for observability. Right? These are things that just traces, metrics, logs, right? Just like some dashboards. And you're thinking, why am I paying through the roof for this kind of stuff? So it was decided to move away. And this was back in, I think, 2023, 2024. We decided to start looking for greener pastures. So that's where the purpose of the talk, Datadog out, open source in. So I was tasked at Yukon Games to be kind of the tech lead behind this migration, to figure out what we're going to be using, how we're going to use it, and making sure it costs less than what we're paying now for Datadog. So I had a very, very high bar, because if it didn't cost less, then, well, right, it'd be a bunch of wasted time. So it was definitely a high-pressure situation. And I also want to shout out the excellent engineering team that I got to work with. It wasn't just me that implemented the solution, obviously. We worked together, and I did a lot of the early on implementation work, but then the rest of the team kept pitching in and evolving it because of the open source nature. So the new observability system had a couple goals. Obviously, lower cost. It had to be open source in some way. We weren't to the extreme. Everything has to be open source, or there's going to be extremists to the nth degree. We can have some pragmatism involved. Maybe we'll keep something that's proprietary. Maybe we'll mix and match. But we wanted 3 features for sure. The pragmatic feature parity for metrics, traces, and logs. Right? We definitely wanted to keep these 3 capabilities. We don't need all the shiny bells and whistles of AI, enhanced queries, and Datadog, and all this stuff that we weren't really using day to day. So, quick recap. Traces, they're just a timeline of actions within your system. And this could go across systems, right? So distributed tracing. It could go from one service to the next service to the next service. And it carries through the same trace ID. And usually uses the protocol to attach some metadata, let's say an HTTP header, to keep that lineage. Metrics, we're all familiar with this. How much RAM am I using? What's my database CPU percentage? Usually aggregated, emitted at some certain time interval, and then it appears in your tool. And finally, logs. So, we all wrote Hello World. I don't have to explain logs, but I feel bad for anybody that writes alerts on logs. Because every time I've changed the log, I'm always thinking, did I just screw up someone's alert? Because back in the Splunk days, you're always writing, analyze the logs, analyze the logs. So there's a lot of stuff there. We can maybe philosophical debate whether you should even interpret logs in any structured fashion. So what did we have to replace? This big black box, the cute Datadog logo, and this Datadog agent. So we're using the Datadog agent to emit traces and metrics. For logs, we were emitting it to CloudWatch logs. So we're just using our cloud provider's existing log solution. And as we all know, CloudWatch logs is amazing, and we all love it. The interface is so good. No, I'm kidding. It does its job. We're not going to give it any praise. So essentially, we emitted that stream there and this here. So after some iteration, right, using the engineering method, figuring out trade-offs, what are we going to go with, what tools are mature, what did we like, what didn't we like, we settled on this stack. OpenTelemetry for the plumbing. This is the definition of how you define a trace, how you define a log, how do you define all the other types of observability in a standard format. That's open source. It's not specific to Datadog. It's not specific to Dynatrace. It's completely vendor neutral. And that's why we chose it. Signos was this open source tool that we saw back at the time. I believe it was version 0.11. It just came out, basically. I found its maturity at the time was really great for traces. The metrics and the alerting was still in the works, and I found we weren't going to use it for that. So that's why we ended up staying with CloudWatch logs. We thought it's already cheap enough. We know we can set some retention, maybe make it only the last 30 days, let's say, for certain services of logs. That's all we need. And then Prometheus for metrics. Prometheus, one of the most used, how many GitHub stars does that thing have? It's been around for decades. And then Grafana for our alerting and visualization. Actually, the year that we kind of were doing this migration, Grafana just released their alerting API. Right? Before that, we technically probably wouldn't have chosen it. But Grafana just incorporated alerting, and that allowed us to really end-to-end close the loop. We were able to then get our alerting based on all these other observability sources and plugged into my PagerDuty phone so that I could wake up at 3 a.m. and have a heart attack. So OpenTelemetry, it's the data plane. Right? If we're familiar, there's a control plane, there's a data plane. This is just about how do we pump all these observability signals into the observability, what they call here front end. I like to call it a back end because it's the back end of the back ends. You want to pump it to Prometheus. You want to pump it to some database, some other type of system. You can plug and play. The OpenTelemetry collector is a high performance piece of software written in Golang. So they're trying to make sure it doesn't add too much latency and it's highly performant. The way you configure it is just through a YAML file. Right? So you're not doing any coding here. It's just a bunch of configuration-driven development. You're able to then instrument via their SDKs and support for various languages like Java, Python, JavaScript. You're able to instrument stuff. For example, Java, you just add a Java agent, and that's it. There's no code. You don't write any code. It auto-instruments your JVM and all the libraries that it detects on the class path. There you go, right? Observability out of the box. Step in Signos. So Signos was where we used the for traces and metrics about the traces. So traces actually generate metrics, right? Their execution time, their status codes, things like that. So we would store this all in a database called ClickHouse, which is what Signos used. ClickHouse is this highly performant C++ database, columnar storage, all the cool new stuff. OLAP queries. It's really good at doing hundreds of concurrent queries, so great for alerting use cases where you need to send a bunch of alert queries every minute or so. We would configure this by instrumenting our ECS instances, which were running our Java microservices, with the OpenTelemetry collector. So the applications would emit that to the local agent running on the node. Right? So this is just a local host call. Cheap, efficient, quick. It would offload that buffering and batching, and we could do some filtering and some other rules on this kind of agent layer. And then eventually this would forward it to a load balancer, which then hits our gateway layer. The gateway layer's job is to then centralize configuration for authentication and also figure out what backend we want to save this to. So it gives us this level of indirection. If we ever want to change where we pump our traces, we don't have to restart any of the agents. Right? The agents are not even aware of where they're writing to. They're just writing to the next hop. That's all they're aware of. And then this hop is able to then materialize into ClickHouse, maybe in the future some other database, or maybe you can do dual write. It's up to you how you want to split this traces stream. So this was our solution. Signos had a UI. So obviously it wasn't just me writing queries. It actually looks a lot like Datadog. The same type of graph for your trace, right? Your timeline, your different services, the different requests, how long they're taking, the trace attributes over here on the right, the container IDs, whatever you want to add to it, and other various high-level information. The one thing that we really liked about Signos was that it automatically created the backend service page. We're all familiar when you go to Datadog, right? You just look at, oh, there's my service, I named it this, there's the dashboard, there's the P99, there's the P90, there's the error rate, all these other things. You get the same stuff out of the box in Signos. No coding, no infrastructure as code, no needing to configure this in the UI. Imagine for like 100 services doing this by hand, it would suck. Then you have the metrics portion of the pipeline. We would configure, not shown here, the OpenTelemetry collector, again in agent mode, but specifically to scrape metrics from Redis, or scrape metrics from Scylla, or the nodes, the EC2 nodes themselves, to figure out their CPU, their swap disk usage, and so forth. We would send those metrics along, and with the same exact pattern, we would use a gateway layer. This gateway layer, again, we can have an auto-scaler. If we're having lots of load, auto-scale up. If not too much load, auto-scale down, so you can save for costs. You might notice here, managed Prometheus. That's not open. That's run by AWS. What are you doing? You're breaking the whole open source mantra, right? Well, it's not always about should you run it, right? You don't want to run too much infrastructure because the TCO. Who's going to be on call for that? Me. I need a break too, right? So we decided to use the managed offering from AWS because Prometheus is such an open source standard. If Amazon ever jacks the price, it's going to be very easy to find someone else who's going to give us a lower price or even just run it in-house, right? So we decided to give ourselves a break. We're already re-engineering so much. Let's use managed Amazon Prometheus. It gives us 6 months of retention by default for metrics and 30-day query windows, which were fine for us. To visualize this information, we use Grafana. So you could just hook it in as a data source. We've all probably used Grafana in this room at this point, one of the most popular dashboarding tools. But the million-dollar question is, great, we've dumped all this data in all these databases. How do we collect all this stuff into one window, right, and control the alerting? And that's where Grafana was used. We would combine these 3 different data sources, CloudWatch, for CloudWatch metrics as well from the AWS account, right? Because CloudWatch has all the metrics from their databases, RDS, all the other components, AWS, and you're able to see those all in Grafana as well. ClickHouse and Prometheus. So by doing so, we use Grafana as essentially this glorified cron runner. We run these cron jobs, and we would have all our Grafana alerts at the time. Remember, this just came out. There was no custom resource, infrastructure as code to set up a Grafana alert. So I actually wrote one. I just wrote a couple of Python functions, which then created a new AWS resource called Grafana Alert. So now in our CloudFormation templates, we could literally instantiate Grafana alerts deterministically, robustly, version controlled. No one's going into Grafana clicking on the UI to set up alert. No. You can games, you have to make a PR. Someone had to review that PR, and then it got automatically deployed by Jenkins to set up Grafana for these alerts. So we'd have close to, I think, 700 alerts, various things. Warning thresholds, they go to Slack. Alerting thresholds, they wake me up. So this was the alerting view. You would have different folders, you could structure them differently, name them. It would show you what's firing, what's normal. And then the cool thing here is in the Grafana UI, it would say that this alert was provisioned via API, meaning you can't actually physically modify this through the UI ever again. It is completely locked down to manual edits, which I found really cool because this feature in Grafana just came out and they already thought of this, right? So I don't know how it's evolved to this day, but I hope they kept that because that was really cool because who hates when you go to some tool and someone's tweaked something manually outside of your CI/CD process? It's like a nightmare. Like, who did that? Who did that, right? And then you're able to explore, construct visualizations, plot Elasticache database memory usage from CloudWatch, all available. Then you can make an alert from this. But the overall lessons learned as we go through this entire stack, I'm not going to read everything, you guys can read it, but you don't need everything, if I can summarize it. You don't need to retain everything. You don't need to collect everything. And if you do, you're going to be bankrupt because there's just so much information. Observability systems are about to give you a statistical model of your system. You're never going to get the 100% truth about your systems. It's always going to involve sampling. It's going to be involving trade-offs, the engineering method. What are some of those examples? Filtering metrics early. You don't want to strain your whole pipeline and then drop the metric at the end. Try to do that as early as possible, because then you don't pay for the networking costs. You don't pay for all the other auto-scaling that might happen as you're loading your entire pipeline. So what we did is we actually whitelisted only the metrics we need, which were the custom metrics, the things that developers in the code would emit manually, right? That they wanted, I exactly want this metric, number of session counts, this. But everything else, go to hell, right? Drop it right there and there on the ECS instance. We don't even send it over the network. And this allowed us to take our Prometheus costs from $20 a day to 8 cents a day, right? So orders of magnitude for metrics that you're probably never going to look at. Next is filtering trace attributes. Again, on the trace side of things. How do we take a look at all these different attributes that we add to every single trace? Every single trace was adding the exact same Java startup command. And you're logging and you're saving this and paying for this to know the exact same value, which you know does not change because you're using Docker, right? We're all using Docker in this room, I hope. Your Docker file is not going to randomly mutate and all of a sudden use Java 26, right? You're going to do that. You know what you've deployed to production.
You can if you don't pin the version.
Yeah, okay. If you don't pin the version and you live on the edge, sure, maybe you don't know what's going on in production, but that's a different problem, right? But this stuff, you know what's going on, and you're paying for this. So we dropped all this stuff, and we saw a 2.5x drop in storage, right? So, and this is compressed storage. ClickHouse can compress up to 10x. So saving 100 gigabytes, and that's like a terabyte of data, right? And you don't have to pay for this. You have to have the headache, okay, how am I going to size my ClickHouse cluster because I'm collecting all this stuff I don't need. Well, don't collect the stuff you don't need then. And finally, trace sampling. This is a chart I pulled from the OpenTelemetry docs, which I say are amazing. Go read them. They're really clear, picture clear. I love all the documentation they have. What are the things that you guys really care about in this room when it comes to traces?
Some errors.
Yeah, errors.
Warnings maybe.
What other things? Like someone makes a web slow traces, right? So that means something's on an index on the table, something's slow in the request path, right? We want to optimize. And then, but you still want some of the good traces, right? Why is that? Why do we want good traces? Control, right? You want something to compare against. If all you're looking at is everything's on fire and everything's slow, well, then you said, I'm quitting. You know, I'm done. Well, everything's just crap. No, you also want to have some positive reinforcement in your life. So you want to statistically have a statistical representative sample of all the okay traces in your system. But you don't want to collect them all because you're not going to have enough money. You're not going to have enough money to capture, especially as you start scaling. If you're getting very successful, you don't want to know that every single person's had a great time because you're not going to have a great time. So how did we configure our OpenTelemetry collector sampling logic? So this was what we injected basically across the agent layer and the gateway layer. I just put it all into one diagram for simplicity. We would get all our traces. We would compute the metrics on all the traces. So we have 100% accuracy at this point. We've sampled nothing. We emit those metrics. So we're going to get really accurate P99 times, really accurate error codes, all that kind of stuff. Then once it hits our gateway layer, we'll check, is it an error? If yes, we want to sample 100% of the errors. We always want to know if someone's having a poor experience. And hopefully we don't have a lot of errors, and it incentivizes us to always fix these errors. Otherwise, we're going to pay a really large bill to store all these errors. Right? So it incentivizes the engineering team to go actually fix things. Is it slow? Is it, let's say, over a second, half a second, whatever your threshold is, right? You would also sample all those traces in our case. And then if it's neither an error and neither slow, do a random 10% sampling. We just want 10% of the good traces for that control, for that baseline. Otherwise, discard the trace. Gone, like it never existed.
Yeah, I'm curious for the is it slow? Did you find like at your company were all of the endpoints largely like in the same kind of performance profile, or did you have did you have to differentiate between different endpoints, some of which you know are going to be slow?
No, yeah. So that's like a great question. Sometimes you're not working on the latest and greatest, where it's all greenfield development, and your guys like, oh, our services are going to respond under 1 second. That's a great goal. But at our company, we found that because our tech stack had no like legacy and all this old stuff, all our services were pretty well behaved, and we tried to always keep up with tech debt to make sure, right? So we could have a global, let's say 1 second. But you're right, there could be segmentation. But OpenTelemetry allows you to do configuration-based sampling. So you could say, if it has this specific parameter, this service name, use a different slow threshold. And that way you can have segments of how you sample. Right? You can say, for this group of services written by this team, we know that their stuff is usually slower, so we're going to give it 2 seconds. We're not going to name the team. It'll be hidden in the configuration. No one look at the file. It's not like a pin of shame or anything. No one look at. But for this team, we know they're super cool. It always has to be under 50 milliseconds because it's super hypercritical real-time transaction processing for Visa. Well, we better make sure that we're going to make it 50 milliseconds, right? Not 2 seconds. So it's configurable.
So you have ability to have SLA attached per server or per a group of services, right?
Not even per group of services, per OpenTelemetry attribute. Whatever you want. Make a custom attribute. It's this specific service that needs this specific SLA. Right?
So I have another question about that. Because as you mentioned, these traces are distributed.
Correct.
So you're collecting this information on different hosts.
Nice, yeah.
And you'll make a decision somewhere to discard the trace.
Yeah.
But that decision affects
other
trace data that might be held back on other hosts. So like
exactly. So for this stuff here, there's 2 types of sampling in the OpenTelemetry world. Head-based sampling, so things that you can do at the beginning of the trace. So stateless sampling. You could use a head-based sampler, it's called, in OpenTelemetry, which just applies a probabilistic function. I think they do some kind of hashing of the trace ID, and then they figure out the distribution and then whether to discard depending on the percentage, 10%, 100%. So we did that naively at the first time. But what does that stop? It's making the fastest sampling decision with the least amount of information, which gives you not the most optimal result, which is this complexity. This complexity, the trade-off that you pay for that, because if you just do 10% sampling, what are the odds you're going to sample all your errors?
10%?
10%?
Not 10%.
Less?
Let's say if you had 10,000 requests and there were only 5 errors.
Oh yeah.
It's a game of odds depending on the relative proportion of the number of successes to errors.
Yeah, so it would be a 10% chance that you sample an error, but much lower that you sample all your errors.
Exactly, yeah. So that's where we started thinking what we need is tail-based sampling. So tail-based sampling, as you allude to, is you have to do some kind of buffering. So these OpenTelemetry agents are actually buffering traces and waiting for them to complete based on the criteria that you're looking for. How do you know a trace is in an error condition? It has to fail. For it to fail, that requires time, which means buffering.
Yeah.
Right? So then that means you have to scale, empirically, you have to figure out how to configure your OpenTelemetry collectors, amount of memory, auto-scaling, distribution, and so forth, and also figuring out how your system behaves. And that's why it's like what you were saying, right? The SLA is very important because it will feed into how you configure this and auto-scale this. Because if you can't buffer, let's say for one request, let's say it takes a minute, and you have a lot of those requests, you're going to end up buffering a lot of stuff at this gateway layer, and you can lead to out-of-memory exceptions. Right? So you have to be very careful how you set this up.
It's like positive feedback on a slow system.
Yes.
As your system is struggling, the cost of your trace buffer will push out the other work.
Yes. Yeah. So you want to be very careful because then this can lead to lost events, drop stuff, and we can talk about that later. But that's kind of the high-level overview of what we did. And if there's anything you've learned from this talk, remember this. Base your alerts off of the metrics on all your traces, not off sample data. If you base your alerts off of sample data, your alert is it's like throwing a dart with your eyes closed, right? Like you don't know did it just happen to sample the errors that you should be alerted for? Right?
Or 10% of
Yeah. Yeah. Works 50%, 80% of it. Yeah, and you get all these, right? Like, so yeah, don't do that. So the final results, we used one ClickHouse node for all of production. We said YOLO, and we configured a disk, just 170 gigabytes of data stored. After all our aggressive sampling policies, we're able to compress all this stuff. And ClickHouse compresses us by 10x, remember. So that's actually 1.7 terabytes of data, right? And we had like a 2-week retention period, something like that. So we only have to use a couple OpenTelemetry collectors, right? You might be wondering, how performant is it? Couple containers. We're able to monitor hundreds of services. Containers, data platform, analytics ingestion pipeline, right? So you don't need a lot of compute to do this. And then the Grafana instance was running hundreds of alerts per minute. And ClickHouse didn't care. It was just like, DDoS me every minute. Do it, I love it. And then we were able to retain a pragmatic feature parity. Right? I'm not saying I replaced all of Datadog. Datadog, I mean, they've had so many engineers, thousands of engineers over years, if not a decade, building out tools. We're going to get nowhere close, but that's not our goal. Our goal is not to be like Datadog. Our goal is to build something enough for our business. And that's the great thing about open source. You can build to what you need, not what Datadog thinks you need and bills you for it. So everyone has to gasp. There are extra Datadog costs found. When we finally computed the costs, Datadog's actually querying your AWS cloud account behind the scenes, depending on what integrations you've enabled.
Yeah.
And now it's pulling in all these CloudWatch metrics, and as we know, CloudWatch metrics are pretty expensive to pull. And it does this, not push-based, does it pulling. So we were paying another extra $20,000 on top of the $70,000. So we were paying close to $100,000 per year for observability on metrics that we never even queried. Right? Or even using our alerts. So you can see the drop off here, right? Like significant. We said goodbye to Datadog on February 7th, and we're like, what the? never come back. Right? So the final observability costs for the open source solution that I kind of pushed out to production, this first initial version, was around $12,000 operational cost versus close to $100K.
Per month?
Per year.
Per year, okay.
So it was almost an order of magnitude different. Right, in terms of cost, and this is we could probably keep fine tuning this more and more, right? But obviously there's a trade off eventually, engineering time versus what you're going to save. But as you can see here, this was a couple of years ago. Cost probably would have just kept going up. We've added way more infrastructure, and this probably be way over 100K at this point, right? And then Datadog, as it starts losing customers, what are they going to start doing? You're going to start trying to figure out how to make more revenue.
It's a lot of frogs to boil.
Yeah, a lot of frogs. Yeah. So the takeaways really are, you can use open source tools for a fraction of the cost. You can retain your core observability, your pragmatic feature parity of observability to ensure your retention and your revenue within your company. That's possible, right? This is just one story, and there's many other stories you probably read about now where people are using open source tools for observability. And just avoiding that vendor lock-in. Try to avoid as much as possible. This doesn't give you perfect, obviously. You're able to just switch backends like this. You just snap your fingers. You're going to lock into some kind of schema, right? Eventually, as we'll see in the live demo, you're going to see some sort of lock-in at some point, right? OpenTelemetry gives you that vendor-neutral data plane, the plumbing, but where you drop that water, those observability signals, it's still going to pull up somewhere. So now let's take a look at the live demo. So the live demo is basically around how do we use our observability backends easily, right? So I promised at the beginning of the talk that each and every one of you in this room will be able to walk away tomorrow at 9:05 a.m., be able to run the entire observability stack open source on your laptop, and by 9:30 pitch it to your boss and say we're switching. So over the course of a weekend, I built a new tool, and I open sourced it. So everyone in this room can download it today. It's live, and it's called TellStack. So think of it as the tool bag, your personal tool bag that you can bring with you to work. And you can run an entire open source observability solution and not wait for DevOps to go spin it up, because you can run it on your laptop.
How did you get a photo of our infrastructure?
That's a good one. So TeleStack, we're going to basically demo, just before we jump into the code and it gets kind of, you get lost, we're going to do an observe improve loop is what I like to call it. We're going to spin up our observability backend, the entire thing locally, by using one command, TeleStack start. Currently, I have 2 bindings that I support. ClickStack, which is made by ClickHouse itself. ClickHouse, the database vendor, has actually got into the observability game, and they're building out their own entire observability backend for everything, metrics, traces, logs. And then Signals, what I talked about during the talk, right? The thing that we use that you can. Zero config, local first, and production grade. Your stack runs, and then because this is a Java meetup, the inaugural first thing that I support to observe is Java. So a Spring Boot app. So we're going to be able to launch TeleStack Observe and point it to a Maven project folder. It will build said Maven project and then run the Java JVM with the appropriate instrumentation. It'll download the OpenTelemetry jar for you. It'll spin up the JVM with all the arguments and weave in the Java agent.
Nice.
All through one command. And then we'll do, just an observation session. What's slow? Let's take a look at the app. Let's go through some of the use cases. How does it visualize in these various providers that are pluggable? Right? So in the future, I plan to expand this support and expand to Python, any other language that OpenTelemetry supports. So why is this unified CLI possible to make today? Because of OpenTelemetry. Right? Without OpenTelemetry, I wouldn't be able to extract all the things and then pipe them to whatever observability backend I want to choose. But this should really help illustrate not only the tool that you guys can use, but visually that it's just so easy now to plug and play these observability solutions. Oops, sorry. So let's jump into the code here. So this is the repo here. It's under the TeleStack organization on GitHub. So you can see I've kept the servers that Jonathan runs here. It's written in TypeScript, so it's pretty easy. I mean, I'm sure everyone has NPM installed at this point. And you can just link it. I haven't published the package just yet. That's on my to-do list. And then all you need, the only requirements are, do you have Docker on your laptop? That's all I demand of you. And Node.js, obviously. So here, we're able to basically support one of these 2 things, but let's just dive straight into the tool. How's the font? Can everyone see that?
Yep.
Yeah? Okay, so we can go TeleStack and we can go help. So what commands do you have? Right, so we can have basically several commands. So let's just do a start as I promised. So we can go start. Here you'll have this selector. You can imagine this will grow as more solutions become more made up. So let's start with ClickStack because we saw Signals. ClickStack's the new hot thing. So this will spin up the Docker containers. It will print out all the various components that you can then browse. And then the documentation link for each provider. And then here we can just go TeleStack, observe, demo, and then Java. So this will compile a pre-made, it's in the repo, the Spring Boot application. Just made some dummy endpoints and some dumb stuff here. This downloaded the OpenTelemetry jar to my computer. I didn't have to figure that out at all. And then it also ran the entire JVM commands to instrument it. So this is now running. I've seeded some test data into the database. We're just using H2 right, in memory. And then here we can do TeleStack. If you just want to see how it would instrument something else, you can go demo Java target, let's say, and the jar. This is what it actually did from a JVM perspective. So it launched this command here, and then you can give it an OpenTelemetry service name. So this is exactly how you would name like a service in Datadog. It would show up like this in your stack. And then we're exporting. You can plug and play. You don't have to export everything if you don't want to. So here we've enabled exporting traces, metrics, and logs for this application, and the endpoint. Right. So this is the local host OpenTelemetry collector that we're running. Protocol, you can do gRPC, I believe, and HTTP protobuf. So this, yeah, go ahead.
Is there any authentication on the collector, or is it always meant to be run on like the same node on a secure channel?
I don't know that off the top of my head, but I believe they do support. I think they do support some sort of authentication. It doesn't have to be agent yet.
I have a question. So you mentioned that retention period is like 2 weeks, right? What about logs? Same retention period for logs?
Oh, you mean like the solution that I built at Yukon?
Yeah.
So the logs, that was being pumped to CloudWatch logs. It wasn't being saved to our open source stuff. We decided to keep the CloudWatch stuff because it was
separate.
Yeah, logs were separate. Yeah, but in this case, this is showing logs are part of the OTel collection.
One question for this command.
Yeah.
So for now, it's all OTel standard, right? Like there's nothing specific.
There's nothing specific to ClickStack here. It has no fathomable idea where this data is going.
That's a big value of what you described.
Exactly, right? That's the biggest value of OpenTelemetry. There's no vendor lock-in here. This is neutral, right? You could pump this just to a log file if you wanted to, right? You just like look at it locally. You don't need to save it anywhere. Yeah, and then I also made another command here. If you're more of like a CLI guy, just some plain output, right? You don't have to worry about the formatting. And then now let's take a look. I have a simple command called telstack UI. So for each provider, I've made it configurable within my CLI, and it will launch the UI for you and take you to the actual UI of the provider you've chosen. Right, so here we can see HyperDX. HyperDX is the UI for ClickStack, the observability solution. So here you can see, let me just make it a little smaller. You can see the logs. This is the logs from the application we just booted up. Right, you can see the timeline here. You can see how many were warnings, how many were debug, info, level, right? Gives you that kind of histogram breakdown. And you can take a look at various aspects of the logs. That's kind of, cookie cutter. Here you can select traces, the traces data source. A bunch of spans we see now, right? Let me get rid of this. There we go. So you can see a bunch of transaction commits, right? Inserts into the database, all this kind of different stuff that was happening. But now let's play around with the app, right? So the app is actually on localhost 8090. Just some dummy UI, right? It's not important what these things are doing. But let's try to add a user. Let's say John, Alexei, and there you are, 67 years old. A few left. And then let's see if this actually captured that trace here. Sorry, there we go. So what I did here is that you see how I enabled root spans. Only show root spans with no parent. A span is a span of time in a trace, right? If I don't have a parent, that means I am the beginning of this trace, right? So the entry point. So the entry point obviously is the request, right? When you're doing requests to load the page, when you're doing the post request, that's my initial thing. So then if we want to take a look at this, we're able to get that same type of graph that we were used to in Datadog, right? There's my service name, the thing that you saw on the Java command line, the instrumentation. And then you're able to then dig down and see, it goes up to the microseconds. Right, and then you have this nice view of everything that you need that Datadog provided you in its view. So you're able to take a look at this all and look around. It also gives you all the attributes on the trace, right? And span attributes. So 302 redirect, right? What HTTP route was it? All the things, user agent, all the things that we expect and love. So that's a simple example. But anyone notice here that when I click refresh here, it's kind of a little slow, right? For something that's doing like an H2, it's like almost like a pause, right? Like what's going on? So let's take a look. What is going on? So we can do live tailing, right? Just like any other tool here. So a bunch of requests. What are people noticing? Let's do some kind of live debugging. What's weird about this? Just yell out if you have any thoughts.
Is that a millisecond?
Those are milliseconds, yeah. So 500 right? But what? Yeah. Why is it consistently half a second? right? So something's off here, right? Like, it's consistently half a second. So let's dive into one of these traces. What does this tell us from a high-level view?
Some select statement taking too long, is it?
No. So it seems like the select statement only took 8 milliseconds.
The web server.
No.
The web server.
Before, right? Something before. This is what we like to call dead time. We have no traces going on here, no spans. The server is doing something computationally. Right? Why is it not? It's not interfacing with any externity. Nothing. No I/O.
Translate somewhere?
Yeah. So it's actually something very complicated.
Recursive Fibonacci.
It's very complicated, right? So if we go to our web controller and we take a look at our just loading the index page, it just does this. Okay, so far so good. Oh, that's so complex. It's doing a thread.sleep. Who pushed that to production, right? So it's just I'm just obviously for demonstration purposes, but it highlights when your server is spinning on something, you're going to be able to see it, right? So let's fix this really quickly, and let's do that observe and prove loop that I was talking about.
So I have a question.
Yeah, go ahead.
Can this Java agent, does it support getting spans at the level of like method calls?
Yeah. I'll show. That's the next example.
Oh, perfect.
Yeah. So here, if we go back and we reload our page, you see it's much faster. Right? Much faster. And then we can take a look at our spans here. There we go. Now it's more reasonable. That's more reasonable to fetch 100 records from an in-memory database and then serve it back, right? All that kind of stuff. So 20 milliseconds versus whatever, it was 500, right? And you're able to see now much more well-behaved looking trace. So that's that one example there. Now there's this cool button. What's this? Add activities to users. Okay, clicked it. That took a while. Let's do some more. Let's really make this slow. So these users are really active. They're doing some kind of cool activities. So we've clicked that button a bunch here. And let's now rerun our stuff here. Let's say we only want to look at those requests. We can filter them. Now we only see these in view. So these are taking over a second, right? So what's going on? So there you go. What does this look like?
From context user
Second
action.
from the top.
And +1 select.
You got it.
Yeah.
It's an n+1 select, right? The dreaded n+1 in Hibernate, right? And then we can actually see this. You see how this says process user? That looks like something custom. Someone wrote that, right? Someone named the span customly. So if you want to instrument certain methods that you know are problematic, you can in OpenTelemetry using their SDK. So if we click on this one, here you can see that we've actually added also some custom attributes. User email, user ID, right? We're able to enrich our spans with whatever data we want. And then obviously, because we've sent those pieces of data, later in your OpenTelemetry pipeline, you can actually write rules to do sampling or anything differently based on these attributes, right? Here, even if you get like your SQL statement here, you'll get the full-blown what it's running, the DB statement, what table, right? What was the connection string, the DB name, right? A lot of useful information when you're dealing with errors or long-running queries. So let's take a look at the code. The code's also going to be a crazy hard to understand. So here's the class here. So here you can see, by getting an instance, I inject this instance of a tracer. So what's a tracer? What is that? That sounds so cool. So if we go here and we go to, where is it? Wait, hold on. Why is it not picking it up? We basically just injected a bean into our Spring Boot application, and we've used OpenTelemetry's SDK to construct an instance. So we construct an instance, and now we can auto-wire this into the rest of our application and get tracing completely integrated into our entire pipeline. Again, that's agnostic. This does not know it's sending the click stack. So here we go back to our code, and we're able to see that we're able to, you want to name it this way, you want to name it that way. Was this your question?
Yeah, well, I know like some tools the agent will just automatically instrument like every method call.
So it depends on the library support. So OpenTelemetry has a really large community, and various Spring libraries have already added custom spans where needed. But if you don't like the verbosity, you can add more yourself.
Okay.
Yeah. So essentially, we can make a new span. That's what this make current does. We're able to add a bunch of extra attributes to our spans. That's what we saw in the UI. This user count, the emails and stuff. We can make sub things like process user. And you can see, as you rightfully alluded to, it is an N+1 issue, right? Where basically it's querying these activities and trying to get their size, but they're lazily fetched, right? So if we go to the actual Hibernate definition, you can see it's fetch type lazy, which checks out, right? And then, you're able to do all this kind of stuff. And I think the most annoying part of this SDK is you have to use try finally. Because if you don't call end, you're never going to get your span.
So you never use the annotations just to annotate the message?
Yeah, I'm sure there's probably libraries that make this.
No, it's out of the box.
Oh, out of the box. Yeah, sorry, I didn't. Yeah, so I wasn't aware of that. But if
you can use an annotation.
You can use an annotation. There you go. Right?
Love that.
So if you use annotations, you can do it this way. The reason I remember doing this way, there was a lot of web flux at UCAN Games. And oh my God, guys.
I'm so sorry.
Do not. You like it?
Yes.
We're going to talk later.
So my experience writing custom spans for Webflux is
writing code in web.
Yeah, debugging it it was just a nightmare, right? So that was kind of this. This shows off kind of this part, right? So you can do all this custom instrumentation stuff, and that sort of concludes that observe improve loop. What are some of the other features of ClickStack? So ClickStack, I think like every vendor, they all try to do this. What is it? I don't know why it's not showing anything right now, but no services found. Let's take a look. Let's skip that. This is the thing with these open source tools. Sometimes it's like they're still,
Is it the time range?
Maybe it's the time range. There we go. Okay. So this gives you that same service page out of the box, right? That we're familiar with Datadog. You don't have to set this anything up. They already have this pre-made dashboard for you for error rates, request throughput, request latency, and then you're able to just come here and take a look at some of your 95th percentiles, all this kind of stuff. Breakdown by endpoint, some of the most time-consuming requests, right? So it gives you like a lot of things out of the box for you that you don't have to worry about. And they have some other presets. If you want to monitor ClickHouse itself, they have some things to tell you what queries are for tuning your observability ingestion. You can look at this dashboard.
Does your price multiply by 2 every time you add a new dimension to your traces?
Yeah, so you got that's always like the cardinality issue. But so you can always like monitor that stuff there. And so forth. They have their alerting. You can build alerts based off dashboards. We're not going to get into that today, but so you can see it right there. Ran 2 commands. It's all on my laptop. I can tune it. I can observe my application locally. A lot of us, let's say, work in big companies where it's really hard to get DevOps to spin up anything or give you the Datadog access key, right? Instead of waiting a week, you can start using this kind of tool locally on your laptop. You have Docker. Start observing your application locally, right? You might get even just some value.
And you can test your code with all those tags, custom tags that you supposed to add, and just see if you really added them there and can trace them and so on.
Yeah. Right, so shifting left, essentially, right? We're shifting left observability, the feedback loop, to our laptops. So now, what was the other thing that I promised? That it's pluggable, right? So instead of, let's say, running just ClickStack here, we can tear this down, and then we can run Signos instead. So we can go with Signos. So Signos has a different set of containers it needs to run, and it will pull those in. It's a little bit slower, so it's not the best for demos. So I'll keep talking and try to fill the dead air. But with Signos, you saw Zookeeper there. That was a good notice. ClickHouse, if you want to run it in clustered mode, you have to use Zookeeper. Who here loves running Zookeeper? For the record, there were 0 hands.
We will cut this part.
So Zookeeper is one of the most annoying things to run because you're just trying to run a cluster and you have to run another cluster to run the cluster. All right. That's one of the reasons I think that we decided to only use one ClickHouse node in production because there was just less infrastructure to manage and monitor. Because the $1 million question, I'm not sure if anyone's thought of this, is what's observing your observability system?
You.
Yeah. Right. So that's the more your complexity you add to your observability system, the more chances there are something to break. And if something breaks in your observability system, you're blind. You're piloting a plane blind. So here we have Signos now. And then if the demo gods are nice, if I do Telstack UI, it should open up the Signos page now. So Signos is a little bit more about security. So they try to make you do passwords and stuff. Here you can see the services page. There's no data here because I haven't touched anything on my app yet. But if we were to do a few, let's say, refreshes of the main page. Oops. Oh, I have to run the app. While that's loading, so Signos has the same sort of services page, the same sort of logs, traces, infrastructure, metrics, right, exceptions, which I find is pretty cool. It'll kind of aggregate any exception that's happening in your traces and then show it in one view. Cost meter, what you're paying for storing all this stuff, and so forth. So you can see here it's on version 116, and when we used it, it was version 0.11. So it's definitely evolved. I probably don't know a lot of the features nowadays, but here we can now load do a couple of requests, add a couple users. Do some of our stuff here. And now our app should be showing up here eventually. There we go, pretty quick. And now here we already see our P99 latency. We see our error rate, stuff like that. You're able to get some initial data points, some top-level spans. If you want entry point spans, same type of deal. That root span that you saw in HyperDX, they call it entry point here. So everything looks kind of similar, right? But now you, as the engineer, you're in charge of what you like more. You have opinions. You have opinions what works for your workplace. So maybe you use Signos. Maybe you find it's easier to set up. Maybe you like their open source and dev relation engineers more. Maybe you like ClickStack more. So you end up going for ClickStack. So it's up to you. I have no opinion. I'm not here to sell Signos over ClickStack or any other platform. I'm just giving you the idea that you're able to do this very quickly locally using my tool or figuring it out yourself, right?
An easy way to run the ClickHouse node somehow in that AWS, so that you run it and you don't care what it's doing.
Great. It's like almost I paid you to say that question. So the question for the people on the recording: is there an easy way to run ClickHouse and not worry about Zookeeper and do all these things and all this stuff? Well, I actually went to a meetup a few weeks ago, and they gave me some stuff to give out to you guys because they love Java user group. And it's called ClickHouse Cloud. So you get $400 for free to run ClickHouse Cloud.
Cash?
Cash. Not cash, no, I wish. I wouldn't give this to you if it was cash. But yeah, some credits. So any good questions after the talk, you'll get one of these.
I'll take all of them.
You have to ask some good questions. So yeah, that sort of concludes the live demo portion. And we can go back to the slideshow. And some parting thoughts, which is, I hope I've given you the confidence to be able to take observability into your own hands, take away the leverage from these vendors, figure out what your cost value ratio is, whether it's with ClickStack, with Signos, whatever open source tool you end up choosing. But you can walk in tomorrow, use TellStack, and demo this to all your fellow engineers. Thank you. Yeah.
Okay. So I'm curious, at UCAN or anywhere else, did you use any tools for like the security monitoring stuff, like processes running in containers that might be suspicious or that kind of thing?
Right. As with all things security, I can't comment on the security practices at UCAN. But in general, I would say we leveraged other tools, not Datadog, for those specific things. And because our security was interesting, it's a lot of client-side security because it's mobile games, right? So there was a lot more, I think, emphasis to prevent cheating on device, as well on the cloud, right? We're trying to detect patterns with our ingestion pipeline, event analysis, all kind of the industry standard things that you'd look at. But yeah, that's as much as I can comment on that. Yeah. Any other questions, discussion? Yeah.
Collectors, right? You mentioned collectors. They have some buffering to kind of calculate this frame, like when the event started, ended, so it has some buffers. So what happens to, let's say, to this data if it's not committed kind of? So let's say if collector crashes, let's say JVM crashes or something like that. Whatever it's buffering, is the data lost? Or?
Right. Great question. So in terms of the JVM, right? If JVM crashes, I mean, whatever was buffered locally before it got sent to an OpenTelemetry collector, you lose, right? There's nothing around that. From my understanding, I don't think there's any durable persistence that you can configure for that at the moment. In terms of the OpenTelemetry collectors, either the agent or that gateway layer that we saw, in terms of that kind of stuff, I actually have something in the appendix that we can take a look at. This is an architecture that someone else built at another company. It's Shivi Gupta on Medium, if you want to take a look at it later. Essentially, what they did is they used Kafka as a durable store for their OpenTelemetry signals. So they would create a few topics for metrics, traces, and logs, and then be able to durably write this stuff there with their OpenTelemetry collectors. Whereas, let's say, if you're just buffering everything in memory, you're doing auto-scaling stuff, it scales down, you're going to start losing those metrics. OpenTelemetry collectors do respect like signals for termination, right? That like shutdown grace window. So you can configure that, but you can't wait forever for a container to terminate. So you're probably going to end up losing maybe some metrics during the day. But it's statistical approximation of our system, right? So by design, observability systems are, there's going to be some data loss. It's not going to be perfect, but this, if you want to get complicated and add Kafka, and thankfully Kafka doesn't need Zookeeper anymore, if you guys have been following along, you can run Kafka to kind of pump metrics and traces and logs to your, let's say, in this case, ClickHouse stack with Signos. Does that answer your question?
Yep.
Okay.
Yep.
Great question. Yeah.
So I'm curious for logs specifically, like a lot of platforms will take just like standard out and do something with them for logs, like say Kubernetes. Do you know what the ecosystem is like for trying to say if you want to get your logs out of like Kubernetes standard out, like send them to OTel?
Great question, because I have a slide for that. So the OpenTelemetry collector pipeline has Kubernetes scrapers. So there's different receivers, right? So the way that OpenTelemetry positions its YAML configuration is in 3 stages: receivers, processors, and exporters, right? So your receivers, you can just collect from OTLP, just like the standard protocol, over gRPC, HTTP. You can have a Prometheus scraper which scrapes your Kubernetes metrics. There's probably bindings, I assume, for logs. I haven't taken a look too deep into that, but you could probably find one for that. I know they do support just listening to log files, like rolling log files on a machine that your agent's able to take, right? They even have one for Postgres, I think. Like it will actually go into Postgres and look at like the most offensive queries and pipe that into your observability. So yeah, there's a lot of different pluggable things. It's all open source, so you can go take a look. I think it's called, the main repo is called OpenTelemetry Collector. And then they have an OpenTelemetry called Contrib, like contributions, which has like a bunch more of these different types of stages. Does that answer your question?
Yeah.
Okay. Great. You get $400. Credits. Any other? Yeah.
I have a quick related question.
Sure.
Is it possible to spin it up like within, like an AWS account, which is like a corporation owned, so that I don't need to sign up for another SaaS service, and I just preferably can I go to the AWS marketplace?
Oh, I see. I don't know about that, but I think they do. I think they might have a marketplace offering where you can put it into your account, perhaps. You have to check the website, but
But if you have a container, you can just.
yeah. But if you have a container, you can run it. You can run it yourself, right?
Yeah, I don't want to do the backups.
Yeah. You don't want to touch any of that.
Yeah.
I would check out ClickHouse because I'm sure they have bring your own cloud option where you can use your VPC or something.
So, and then if I understand, technically all you need is a ClickHouse node, a couple of OpenTelemetry collectors, and that's pretty much it. The UI.
Yeah, then you just slap on HyperDX, right? If you want to use ClickStack, you have HyperDX. HyperDX, fortunately or unfortunately, has an extra dependency called MongoDB, which uses it for application state for their kind of stuff. They decided not to just use ClickHouse for that.
The demo you showed us, did you build the container yourself or did you download it from there?
Oh, I did a lot of work. No, no. So my CLI aggregates whatever, let's say quick starts they have, and I just put it under my CLI, right? And then if I want to expose certain features, I know how to tweak and tune those containers.
ClickHouse itself,
Yeah, ClickHouse has a container.
Okay.
Sorry, ClickStack.
You just took it as a.
I just took their reference Docker container, and then you can configure it how you want, right? Like what port you want to expose this component on, this component on.
You could do the same thing.
Yeah, you could just take that all in one container and just run it if you wanted to. Like the most bare bones, right, thing you could do. Yeah.
If you could switch to previous slide where you had those processors and this OpenTelemetry. Yeah, this one. So basically, as I understood the architecture before from the previous slide, where your Java application would call the hotel collector, right? And hotel collector would accumulate or would it pass through? Because here on this slide, I see arrows pointing in a different direction. So basically, if that one was a push, this seems to be falling.
Yeah. So OpenTelemetry receivers can be designed in two ways: push or pull.
Like they could be push or pull, or they could be push and pull at the same time.
Depends on the implementation.
On the implementation.
Yeah.
So basically, like for example, that I don't know, Prometheus receiver would be a scraper, which would be a pull one.
Exactly.
Scrape something, and another one could be an opposite, like listening.
Exactly. Yeah, like a port.
Okay.
Yeah.
And then processors are always in and out, right?
Processors are always in memory transforms or filtering, right? So if you want to exclude certain traces, like we saw on the previous slide, you would write something like so. You could write a filter metric, filter processor, add it to your pipeline that goes from your receiver to your exporter in between, name it something, let's say whatever, custom metrics, and then you can use the pre-configured configuration that processor supports. Whoever wrote that Golang component exposes these configurations for you.
Okay. So this just feels like pretty complex architecture, 3 layers. Does it have to be this way, or could it be simplified and passed through, or?
No, yeah, you could pass through everything. But remember what I was talking about, this slide actually perfect. You might pay more, right? If you pass through all your stuff through your stack, and you don't end up filtering anything.
That's actually a very good slide. So
Yeah.
sorry, maybe it's a long question, but that's exactly where I understood it in one way, and then now in the later slide, I think it's maybe contradicting, at least in my head. Like here in this hotel collector specifically, you said that you'd be dropping useless metrics, right? So
Correct.
you wouldn't be even leaving from ECS instance.
Correct.
Right? But now in that later slide, you have these like three layers, these processors and so on. That feels like there would be not just hotel collector, but much more components into it.
This slide maybe is a little confusing, but this encapsulates the entire OpenTelemetry process. These things are inside the OpenTelemetry collector Golang process. Yeah.
So an additional question about the filter part of it. Like, if we want to drop some useless like metric attributes so that cardinality doesn't
Explode,
go on
yeah.
us? Like that example with the process command line. Like
Yeah.
We probably don't care about it.
Yeah.
Do we have to do it on the collector's side, or can we configure the, say, Java agent, for example, so that it doesn't include it?
So, great question. So the question just for the recording is, can we exclude trace metrics and trace attributes, not on the OpenTelemetry collector, but earlier on the Java agent? And maybe I failed to say that, but this is actually pointing to the application. So this stuff, I actually configured the OpenTelemetry Java agent to exclude. So it never even leaves JVM memory space, and it never even hits the Golang service. Right? So even more efficient.
And that would be like another like command line argument to the collector.
Yeah, it's all through command or environment variables. Yeah. Any other questions? There's two more for $800. $800 on the line. Yeah.
That's not a question. So the thing is it possible just to run it locally and point it to some like non-product environment just to grab metrics and see how it works?
Point what locally?
Like locally deployed stuff to some like some deployed somewhere working server just to grab some metrics from that.
Deploy OpenTelemetry?
Yeah. Not OpenTelemetry. OpenTelemetry will be there
Yeah.
on the server, but the TelStack.
Oh, TelStack. So TelStack is just a CLI for your local environment, right? That's a good idea. Like I could probably add more commands there if you want to run, let's say, an OpenTelemetry collector that ends up, let's say, scraping something
That's
in your environment. That's actually a really good idea. Yeah, I could add that where like essentially you run a command and you say observe, but instead of it just like being a local JVM application on your file system.
You should do some like additional alpha stuff probably, but like that's like why should you like just you can do it locally and just grab it?
Yeah, and then that way you can just pull in some data from your cloud account and then visualize it locally. Yeah, that's a really good idea.
You should write a scraper for Datadog.
yeah. So you say that, but one of the outputs is Datadog in OpenTelemetry, funnily enough. Right? So if you guys want to be vendor neutral and then send it to the vendor, go ahead. But sorry, can you pass this back?
Yeah.
And then one last question? Going once? Going twice? Yeah.
That's probably a bit more of a question about the process itself, but just was curious about, did you consider this option to probably call to Datadog and ask about discount first, like before running all this stack? Probably, if you would tell them that you're gonna leave and build your own like in-house solution,
Oh yeah.
they would maybe, I don't know, just wondering, maybe they would give you a discount or something.
Oh. So the question was, did you guys consider calling Datadog and negotiating better? So, I mean, do all of us in the room, we look like engineers. So we don't have the best negotiation skills. But no, that's a funny joke. We did obviously talk with the vendor, right? We tried to negotiate, but they were just like, no, that's the price, right? So when people say that to you, then it forces your hand, right? And you end up doing this stuff, and it's only getting easier. When we built this entire thing that I was talking about, You Can Games, that was several years ago. It's only gotten way easier. The community is way more mature now. The tools, the documentation. You have AI. I had no AI. I was reading like source code, like, what does this stupid OpenTelemetry thing do? Like, I have no idea, because the docs is like some guy on a weekend who maintains it once a year. It's like committing to this repository, right? So it's like, why is it? And I had to build a production grade pipeline, right? That's when now it's so much easier. I wish I had even just like articles like this. Wow.
Like, it forces your hand because like after that you were forced to do this, and you said like 90%. If you negotiated 20%, you were never.
Yeah, you never would have seen. Yes, exactly. Yeah. So the response in the room was, if you negotiate with the vendor, they'll give you like 20%.
Yeah.
But then you miss out. You never know what you didn't know. You never knew that you could actually save 90. Right. So, but yeah, I think we're at time. Maybe one more question. Yeah.
Yeah, thank you. Maybe you mentioned that and maybe your manager calculated how much time, like in total, like man hours was
Oh.
to build this thing.
Yeah. So I can't say the exact number of hours, because I know there's a lot of smart people in this room, so they'll reverse engineer salaries. But let's say the solution we built at UCAN, it pays for itself in less than 2 years. Yeah.
Thank you. That's very good.
Yeah. Cool. Okay. Thank you.
You forgot to do certificate.
Sure.